Next, let us study about flowchart. So I have told you that first a programmer will analyze a program. He will understand what the problem is. On the basis of that analysis, he will write a step-by-step procedure for that problem, which is known as algorithm. And on basis of this algorithm, he will write code for that particular problem. In between this algorithm and writing a program code, there is another step which is known as flowchart. Flowchart means it is the diagrammatic representation of steps to be performed, steps taken to perform a task. That is, in algorithm we are writing step-by-step procedures, and in each step we write short sentences. Okay. These short sentences, they can be converted into the form of diagrams and shapes. That is what we mean by this flowchart. Okay. Whatever we are writing inside the algorithm, they are in short sentences. That is, each step they are in short sentences. We can convert the short sentences into different diagrams and shapes. That is what we mean by flowchart. For example, see, I want to understand a story and I am given two options. First option is I can read a book and understand the story from that particular book. Second option is I can watch a movie of that particular story. Which one would you prefer? See, most of the people would prefer the second option, watching movie. Why? Because you can see pictures which are attractive to our eyes. Of course, some of the people might read book because it is their habit. But for the rest of the people, for majority of the people would prefer watching the movie because we are seeing pictures which are attractive to our eyes. This is similar in the case of flowchart. Algorithms, we write them in short sentences. Some of the people might not prefer them, or some of the people might not understand what this is. For such people, for an easier purpose, they use flowchart. Okay, that is, each step inside this algorithm, they can be represented in the form of diagrams and shapes, which are easier for people to understand. Okay. So flowchart means it is a diagrammatic representation of the steps taken to perform a task. And in flowchart, each step is represented in the form of geometrical shapes. Different shapes are being used inside a flowchart. Each shape, they are connected using arrows. Okay, for connecting each shape, we use arrows. And these arrows are responsible for the direction of flow of each step. So we'll study about each shape and how the flow of the steps goes by using an example. Okay. Next, let us see different shapes which are used inside a flowchart and their uses. First shape is oval or rounded rectangle. It has been used for start or stop box. Okay, and its use is used to show the start and end of a flowchart. Okay, so for indicating the start and stop, we use oval or rounded rectangle. Second one is rectangle. The name of the symbol or shape is process box. Okay, and it has been used to show the processes or actions. So whichever process you want to show, you should represent it inside the rectangle. For example, sum is equal to a plus b. It is a process, so you should write it inside this rectangle. Okay, whatever processes are to be indicated in a flowchart, they should be written inside this rectangle. Next shape is parallelogram. It has been used for input or outputting. Okay, used to show whether a data is input or output. So for inputting and outputting, we use parallelogram. For example, input a, b, c, or output sum. All this will be written inside this parallelogram since they are input and output. Next one is diamond, used for decision. Its name is decision box, and it is used when you need to select between two options, commonly used as yes or no. That is, whenever you want to check a condition, okay, true or false condition. In such cases, we will be using this diamond. Whenever a condition comes or whenever we want to take a decision, we use a diamond shape. And next one is arrow. The name of that particular shape is flow line. It is used to connect different shapes in a flowchart and indicate the direction of the flowchart. That is, all the shapes, they are connected or they are indicated by using these arrows. Okay, so these are the different shapes which are used inside a flowchart. For start and stop, we use oval shape. For processing, we use rectangle. For inputting and outputting, we use parallelogram. For decision making, we use diamond. And arrows, they are being used to show the path of this flowchart. Okay. Next, let us see the steps for designing a flowchart. First step is list the steps of the process. That is, you have to write the algorithm first. Only on the basis of algorithm we can design a flowchart. Okay, so first you should write the algorithm, and on basis of this algorithm we will draw flowchart. Step number 2, begin with start symbol. Of course, algorithm begins with a start. Okay, so your flowchart also will begin with a start symbol. Which is the start symbol? Oval shape is the start symbol, and inside that we will be writing start. So flowchart always begins with this start symbol. Step number 3, write the first step in appropriate symbol. In most of the algorithm, second step will be inputting. Okay, for inputting we use a parallelogram. Inside that we will be writing input A, B, C. Okay. So for inputting and outputting we use a parallelogram. Step number 4, write each successive steps in its respective symbols. So after inputting, processing comes. For processing we use a rectangle. Okay, we use a rectangle. And inside that we will be writing the formula. For example, sum equal to A plus B plus C. Okay, so for processing we use a rectangle. Then step number 5, add arrows between symbols. That is, for connecting each shapes we use an arrow, and arrow shows the path of flow of that particular flowchart. And step number 6, make sure all the flow paths reach the single stop box. So at the end of the flowchart, all these arrows, they should come and join at the stop box. For stop also we use this oval shape. Okay, inside this oval shape we will be writing stop, and all these arrows, they should come and end at this stop symbol. Okay, so these are the steps for designing a flowchart. Next, let us see the rules for designing a flowchart. First rule is a flowchart has only one start and stop box. Okay, always a flowchart starts with a start box and ends with a stop box. And second one is the direction of flow in a flowchart is either from top to bottom or from left to right. Okay, the flow inside a flowchart is from top to bottom or from left to right. Third one is the flow of control follows only one path. Okay, that is, the arrows, they move only on through a one path. There is only one path for the flow inside the flowchart. So these are the rules for designing a flowchart. Next, let us see how we can write or draw a flowchart for making a sandwich. Okay, first we have to write the algorithm before we are drawing the flowchart. In algorithm, step number 1 is start. Step number 2, take 2 slices of bread. Step number 3, apply cheese spread on one side of the first bread slice. Step number 4, spread mint or tomato sauce on the second bread slice. Step number 5, place cabbage leaves, cucumber and tomato pieces over the cheese. Step number 6, sprinkle seasoning and place the second slice over it. Step number 7, sandwich is ready to eat. And step number 8 is stop. Okay, so now let us see how we can draw a flowchart using this algorithm. First step is start. Okay, so we are drawing an oval shape and we are writing start inside it. Next one is inputting. Okay, so for inputting we use a parallelogram, and inside the parallelogram we are writing take 2 slices of bread. And next one is processing. Okay, so for processing we use a rectangle, and inside the rectangle we are writing apply cheese spread on one side of the first bread slice. Again, next step is also processing. So we should write again draw a rectangle and write inside it spread mint or tomato sauce on the second bread slice. Again, next step is a processing. Okay, so inside that we'll be writing place cabbage, leaves, cucumber and tomato pieces over the cheese. Again, a processing comes, that is we have to sprinkle seasoning and place second slice over it. And last one is output, that is the sandwich is ready to eat. We are writing it over a parallelogram, that is output should be written inside a parallelogram. Okay, so sandwich is ready to eat, we are writing it inside the parallelogram. And at last inside the oval shape we'll be writing the stop command. Okay, see, we started by using a oval shape. Inside the oval shape we wrote start. And next step is input. So we are using a parallelogram and we are inputting. Then comes the processing. For processing we use a rectangle. And at last the output comes. Output has been written inside the parallelogram. And last step is stop, which is written inside the oval shape. Okay, this is a simple example of how to make a sandwich. And we are representing them by using a flowchart. Okay. Next, let us see an example of a flowchart. That is, I want to draw a flowchart to find the average of three numbers. So we have seen the algorithm of finding the average of three numbers. Okay, first step was start. So here we are using the symbol for start, that is oval shape. Okay, then second step was you have to input A, B, C. So for inputting use a parallelogram. Inside that you are writing input A, B, C. The next one is processing. So that is you have to find the sum of three numbers, which is a processing. So for processing use a rectangle, that is sum is equal to A plus B plus C. And after finding the sum you have to find the average, which is also a processing step. So we are again drawing a rectangle and inside that we are writing average is equal to sum divided by 3. And next step is you want to see the output. You want to print the output. Okay. So I am writing print average inside a parallelogram. So for outputting also we use a parallelogram. Okay. So I am drawing a parallelogram and inside that I am writing print average. And last step is stop, which comes under the oval shape. See, a flowchart always begins with a start and always ends with stop. Okay, and there is only one start box and there is only one stop box. Okay, see, and look how the arrows goes. From start the arrow goes on to the inputting, then arrow goes on to the processing. Again the arrow goes on to the next processing. Then arrow goes on to the output. Then at last the arrow ends at stop symbol. Always the arrow should end at the stop symbol. Okay. And see the symbols. For start we use oval. For inputting we use parallelogram. For processing we use a rectangle. And for again outputting we use a parallelogram. And at last for stop symbol we use a oval shape. Okay. So this is how we draw a flowchart for finding the average of three numbers. These are the same steps which we wrote inside the algorithm, but we are making them little more shorter and precise. Okay, by using this symbols and diagrams. Okay. This topic is about decision making. That is, sometimes while we are solving a problem, certain type of conditions come. For example, if A greater than B, if A greater than 150. See, these are conditions, and for this type of condition either a true or false comes. Okay, either the answer can be true or the answer can be false. Okay, so after checking these conditions, a computer can proceed further to show the results. This is what we mean by decision making. That is, sometimes while you are solving a problem, a computer can proceed further only if certain conditions are met. Okay, for example, if A greater than B. For the condition A greater than B, two cases can come. Okay, first case is either the condition can be true. Second case is either the condition can be false. Okay. So computer can proceed further only if these conditions are met. And after checking the conditions, a computer proceeds further to show the results. This is what we mean by decision making. And a computer uses if-else statement for decision making. Okay, for decision making, a computer uses if-else statement. And look at two cases. When the condition after if is true, the computer follows the instruction after then. Second one is when the condition after if is false, the computer evaluates the instruction after else and then proceeds further. This process is also known as conditional problem solving. See, you will be able to understand these two conditions while we look at the example. Okay. When we look at the example, you will be clearly able to understand what we mean by these two conditions. And I will explain to you what we mean by this conditional problem solving while teaching about the example. Okay. So decision making means while we are solving a problem, a computer can proceed further only if certain conditions are met. For example, if A greater than B, it is a condition. And there are two cases for this condition. The first case is the condition can be true. Second case is the condition can be false. And after checking this condition, a computer will proceed further to show the result. This is known as decision making. Okay. And computer uses if-else statement for decision making. Let us see an example. First, we'll write the algorithm for the problem. My problem here is I want to find whether A is greater than B. Okay. So first step is I have to start. Second step is input A comma B. And third step is I have to write the condition. My condition is if A greater than B. Okay. So if my condition if A greater than B becomes true, then my computer will follow the instruction after then, that is print A is greater. Once again, here I am checking a condition, that is if A greater than B. There are two possibilities, either my condition can be true or my condition can be false. If my condition is true, then computer will follow the instructions after that, that is print A is greater. If my condition, that is if A greater than B, if that condition is false, then computer will skip this part and come over to the else part and it will print B is greater. Once again, my condition here is if A greater than B. If my condition is true, then my computer will follow the instructions after then, that is print A is greater. If my condition, that is if A is not greater than B, then computer will skip this part and it will come over to the instruction, that is else part, and it will print B is greater. And last step is stop. Now let us see the algorithm for this particular problem. First step is start. So my start symbol comes, which is inside oval shape. Okay. Next one is step 2 is input A comma B. So for that I use a parallelogram. Inside that I will be writing input A comma B. Then my condition comes. So for decision making we use a diamond shape. Okay, we use a diamond shape for decision making. And since here we are checking a condition and the condition can be either true or false. So my flowchart is being divided into two parts. Either it can be condition can be true, that is yes. Otherwise my condition can be false, that is no. Okay. So two arrows are being drawn from this diamond shape. Okay. If my condition is true, that is if A is greater than B, then I will be moving on to this S part and then I will be printing A is greater. If my condition is false, I will be moving on to the no part and I will print B is greater. Once again, in a flowchart for decision making, we use the shape diamond, and inside the shape I have written is A greater than B. And since this is a condition, there can be two possibilities. Either my answer can be true or my answer can be false. Okay, so I am drawing two arrows. First arrow is for yes and second arrow is for no. If my condition is true, I'll be going on to this arrow and I'll print A is greater. If my condition is false, I'll go on to the no arrow and print B is greater. Okay. And see, the arrow that comes from the no, it will go and join over here, and a single arrow is the one that goes over to the stop symbol. Okay. At last, I'll draw the oval shape and I will write stop over this. See, all the arrows at last they end at the stop symbol. Okay, all the arrows at last, even though they are be divided in between, all the arrows at last they come and come and end at the stop symbol. Okay, and this arrow, that is the arrow that comes from no, it should come and end over here. Okay. So this is the flow chart for this particular condition. And this is what you mean by conditional problem solving. What do you mean by conditional problem solving? That is, here a condition has been given, whether A is greater than B. And two possibilities are there. Either it can be true or it can be false. This is what you mean by conditional problem solving. And see, while we write an algorithm, we use the words like if, then, else. But when we write or when we draw a flow chart, instead of this if, we use the word is. Instead of then, we use the word yes. And instead of the word else, we use the word no. Okay, this you should remember this. That is, whenever we write an algorithm, we'll write the condition like if A greater than B. Then we'll be using the word then, else, etc. But when we come to the flow chart, instead of if, we will write the word is. Instead of then, we'll write the word yes. Instead of else, we'll write the word no. Okay, you should remember this also.
Look at another example. You have to print whether a student is eligible for a third language or not based on the percentage of marks scored in English. Okay, so our condition is that we have to look the mark for English. Okay, and based on that mark, we will be printing whether a student is eligible for third language or not. Okay, so first look onto the algorithm. Step 1, start. Step 2, we are inputting the mark of English. Okay, and step 3, if English is greater than 90, that is the mark for English is greater than 90, then if the condition is true, then print eligible for third language, and if the condition is false, eligible for third language. Step number 4, stop. Okay, so here the condition is whether the mark of English is greater than 19. If the condition is true, we will print eligible for third language. If the condition is false, we will print not eligible for third language. Now look on to the flow chart. First we'll start. Then we are inputting English mark. Okay, and inside the decision box we are entering is English greater than 90. And look, the arrows goes on to the two path. One path is for yes and another path is for no. Okay, if the mark of English is greater than 90, then we'll go on to the yes part. Okay, that is print eligible for third language. The condition is false, we'll go on to the no part. That is print not eligible for the third language. And at last, both the arrows come and end at the stop. Okay, so this is the algorithm and flowchart of finding whether a student is eligible for a third language or not. Okay, and with this we come to the end of this chapter, that is chapter number 4, algorithm and flowcharts. Okay, thank you.